Put on Jumbo. Start it. Come on. Good evening, sir. How are you? Good evening, sir. Coming. 1 minute.
I am also coming.
Yeah, we are on the way.
Good evening, Chanti.
Good evening. 5:30 5 start jaru. 5:30 na. Venkatramana sahab, namaste.
Namaste. Airport నుంచి వస్తున్నా తమ్మి.
అనా?
Airport నుంచి వస్తున్నా.
సదావత్సలే సమనామధేయ సదావత్సలే. Good evening, Ramesh sir.
Namaste.
How are you, sir?
Namaskaram, fine, sir. Fine. Good luck.
Good luck, sir.
Namaskaram, sir. Ramesh Kumar, sir.
Okay.
నమస్తే వెంకటరమణ గారు. నమస్తే సార్.
నమస్కారం వెంకటేశం గారు. నమస్కారం.
నమస్తే వెంకటేశం గారు. సార్ నమస్తే సార్. రమేష్ సార్ నమస్తే. నమస్తే. నాయక్ గారు మీరు ఎక్కడ ఉన్నారు? సార్ నమస్కారం సార్. నమస్తే. మీరు లేకుండా మా ఫైనాన్స్ మీటింగ్ జరిగింది. నేను రాలేకపోయాను నిన్న. నాకు తెలియదు నిన్న ఉందని. నేను కొద్దిగా నిన్న బయటకు వెళ్ళి వచ్చాను. లేట్ బై ద టైమ్ ఐ కేమ్ బ్యాక్ చెప్పాను నేను. అదే ఇక్కడ ఎవరున్నా లేకుండా మీరైతే ఉంటారు అక్కడ.
వెంకటరమణ గారు నమస్తే.
నమస్తే.
మార్నింగ్ V6 లో గుద్ది పడిచింది. V6 లో
చూసినావా?
బ్రహ్మాండ మొత్తం జల పంపకాలు జాతీయ ద్రోహం. తెలంగాణ జాతీయ ద్రోహం. వెంకటేశ్వర రావాలి టీవీలో. మేము ఇక్కడే ఉన్నాము సిగరెట్ లో పాస్ పోయినాం.
మెచ్చుకుంటున్నావా తిడుతున్నావా?
రమణన్న ఇవాళ సమనామధేయము. మనం ఒకళ్ళ మెచ్చుకోవాలి, తిట్టుకోవాలి, ముద్దు పెట్టుకోవాలి. నువ్వు ఎంఐ ఉన్నావు, ఎఫ్ఐ కావాలి. ఇంకా ఎంఐ పెట్టు పక్కన. అన్నగారు
हुसैन भाई सलाम।
Professor Mohiddin, good evening.
Good evening, sir.
How are you, sir? Professor sir.
Very fine, Professor Anna.
हमारे डी साहब और प्रोफेसर साहब प्रणाम.
అన్నా భోజనాలకు వస్తలేరా అందరూ?
భోజనాలు మా సుబ్రెడ్డి గారు భోజనం అయింది. గర్భాలు పెట్టుండు నాన్ వెజ్ తో.
డిన్నర్ ఫాలోస్ రాత్రి.
యా యోగా ఇప్పుడు యోగా ఓన్లీ ద్రవపదార్థాలే, నో చికెన్ మటన్.
యోగా డిన్నర్.
మజ్జిగ, పాలు, పెరుగు, వెన్న.
హలో.
యోగా డిన్నర్ అంటే యోగా చేయించడే యోగా డిన్నర్.
ఎస్ అన్న,
యోగా చేసుడే.
చెప్పారు.
ఉపవాసం పండి పెట్టడే యోగా డిన్నర్ అంటున్నా.
మన డిఏ ఉండి ప్రొఫెసర్ బాబు అందరూ ఆల్ ఇరిగేషన్ R&D డిపార్ట్మెంట్ స్టూడెంట్.
Sustainable management of water resources using data, computational tools, and the cyber infrastructure. I take the privilege to welcome respected chief guest and speaker Dr. Venkatesh Garwade, Principal, Department of Civil Engineering, Urdu University,
Padyu University, USA.
In which country, sir?
USA.
Okay.
Babu.
Dr. Mohammed Hussain, Department of Civil Engineering, Engineering and Technology. And Vishwanath Kota, and also joint secretaries, past chairman, past presidents, council members, dignitaries, and virtual mode, past secretaries, members of Telangana State corporate members of engineers, representatives of media, ladies and also joining here. Today, actually, it is great to honor to be attending this August hybrid gathering. I say hybrid because on hybrid mode, both physical and virtual. And extend a warm and hearty welcome to the today's chief guest and keynote speaker, Dr. Venkatesh Garwade, Professor, Department of Civil Engineering, Urdu University, States of United States of America. And we are very thankful to you to accept to give a lecture from ESA and case of Northern and all of you to this sustainable management of water resources using data, computation tools, and cyber infrastructure. I am also very happy to be associated with this memorable event. The institution of India is founded in 1920 and incorporated by a manufacturer in the year 1935. Recognized as a representative body of engineers in India, which is bestowed statutory authority and responsibility by the Higher Charter for the promotion of science, practice of engineering, all disciplines. The institution is multidisciplinary body of engineers having commerce and
స్కూల్ పెట్టాలి.
state and local centers across the state capitals in the country, and the 7 forum and one specific areas of activities. The institution is working relentlessly for national development, both various membership categories of the fellow member, associate member, senior.
I don't know. The voice is not very clear.
Sir, voice is not clear, sir.
As a parliamentary body and society engaged in spreading
Your voice is
proud to say that the institution has improving itself, being the forerunner of Bureau of Indian Standards, Indian Name Academy of Engineers. Interestingly, the institution of business engineers, which has accredited IIT Thailand for the first IIT in the country in the year 1956 as the creation of the government of India. This initiative to enable practice of ethical ethos and pursuit of professional excellence for engineering fraternity to serve the humanity through inclusive growth. The vision of the institution of engineers is to effectively promote the general advancement of engineering science and technology and their applications in India, and to facilitate dissemination and exchange of information and ideas among the members in the profession and the persons attached to the institution of engineers India, and to extend value-based services to the nation at all desired levels. The institution has been playing a leading role at international level to collaborate with innovative ideas and to raise the bar in the engineering profession. The IIT has 6 overseas chapters and related types with 31 sister professional societies of the international level across different countries in the world. And I would like to place few words about the Telangana State Center. I am proud to announce that this is the only center out of 125 which has been awarded the ISO 9001-2015 certificate in 2 years. And also proud to announce it is fact that it is in formation of 6 years. In the 2016 August, it was formed out of the division of the AP state. So a good match is somewhere, and it has the best states that are going back 2021 to 22 and 18, 19 and 19, 20 having more than 10,000 corporate members on its roads and more than 19,000 corporate and non-corporate members in its board. One of the most active centers of the IIT, which is assistantly translating the objectives, vision and mission of the institution of education to practice. And also, I am proud to inform this August gathering that it is playing a very important role in dissemination of information on engineering and contemporary technology, bringing industry, academia, experts, professionals together.
Voice is very weak. Speech is not clear, please.
National conventions, all India seminars, workshops, roundtable conferences, panel discussions throughout the year. Almost one program every third day. And I am also proud to announce that this is the first unit of the institution of engineers and across all along the bodies which are conducting conferences all over India, including academia. This means we are the first in India to organize a convention for 2 days on rising technology, creating value for the industry and society. It soon after it was launched by the Honorable Prime Minister in the month of August. I'm also proud to announce that this is the first center to organize another convention in mechanical engineering on the topic of developing advances in battery technology for electric vehicles. And although within this span of 4 months, a third convention was also held here with the collaboration with the Safety and Quality Forum of New Delhi by announcing quality creation awards to the eligible industries and the service sector. So I am very proud to say that the institution of engineers, Telangana State Sector, has been organizing 20 endowment lectures every year, and the partners in the honor of the eminent engineers, the one like now, Engineer Hanumantha. The leader of the engineer, please look at our endowment lecture. Engineer Endowment, and Professor K. Gopichand, Dr. J. Purushottam, Engineer G. Prabhakar, Engineer Kokar Vishnu Rao, Engineer G. V. Subbarao, Engineer T. Hanumantha, Engineer A. P. Ranganatha Swami, Dr. S. Raghavachari, Dr. Nada Babarao, Engineer Madhur Gopal Rao, Engineer Gurram Kotredi, Engineer Abdul Venkateshwar Rao, Dr. John A. Murray, Dr. L. V. Anand Rao, Engineer L. Venkateshwar Iyer, K. V. Srinivas Rao, and L. L. Swami Endowment Lecturer, Dr. A. Ramakrishna Endowment Lecturer, and Engineer Hari Basona Endowment Lecturer. So these are the endowment lectures being delivered by the people of high eminence with considerable professional experience to throw light on the important emerging topics of today's relevance. And today's topic is suitable, sustainable management of water resources using data, computational tools, and cyber infrastructure. By Dr. Venkatesh Narwade, Professor Department of Civil Engineering in VSA, Babu University. Since we are anxiously waiting to hear a talk from our eminent speaker, I am repeating myself here and hope that you will really enjoy this talk. And on behalf of the Telangana Institute of Engineers and my own behalf, I once again extend a hearty welcome to the chief guest speaker and Dr. Hussain, Dr. Hussain, Professor of Department of Civil Engineering, and other family members, and also everyone. And now, I request Dr. Mohammad Hussain, the Professor of Bokara Institute, to kindly to present the life achievements of the Thank you. I hand over to Professor Hussain sir to kindly present the library achievement of the Hanumantha, the legendary engineer whom we always respect. We remember on every his birthday. Of course, we remember every time whenever we meet because he is Disha Hanumantha. A great opportunity for me to express homage. Thank you very much. Over to Professor Hussain.
Good evening to all of you. Good evening to all of you, and also I welcome all of you to this August function. I pay tribute with a deep sense of respect to my mentor, philosopher, guide, Engineer T. Hanumantha Garu, who attained Mahasamadhi on 8/1/2017. He was an honest in a at the highest degree of unconscious 6 years of age. So I know him for the last, and when I was undergoing 10-month long term, was then Director General of the rank of Engineering Chief. So he gave his highly technical inaugural address of first national seminar at our college, Gokaraju Rangaraju College of Engineering and Technology, on sustainable technologies in civil engineering, perspectives and strategies, steps in the year 2011 at Gokaraju Rangaraju Institute of Engineering and Technology. He again visited BEAT our college as chief guest on the occasion of United Nations World Water Day on March 22nd, 2016. So during my training in the year 1987, I underwent training in yoga at Gandhi Gyan Mandir at Koti in Hyderabad, and it has a profound effect of transformation on my personality development. And incidentally, today is also International Day of Yoga, and he encouraged me to bring out a booklet, Know Yourself series. So he has given considerable. So he has actually encouraged to bring out that booklet, Know Yourself series, and regarding his habits, character, and values. He used to wake up at 3:30 a.m. every day with the daily practice of yoga asanas and pranayama. You find in him all 7 habits of Dr. Stephen R. Covey in his famous book, The 7 Habits of Highly Effective People. That's the reason why, for all the toppers of 4 colleges, so we are giving gold medals in the honor of Engineer T. Hanumantha Garu, and to them I am also presenting on my behalf 4 habits of the 7 habits of highly effective people. That book also I'm giving. I'm donating. So now, he had a general understanding of all other scientific aspects like astronomy, genetic engineering, nuclear science, psychology, geology, physics, chemistry, sociology, political science, economics, and other kinds of engineering, etc. He was an all-rounder with thoroughness in all fundamentals of engineering and science. So his method of study was to write with his own handwriting and then review it frequently. He showed me many such written books. So that exactly comes under SQ4R method, okay, of study. Internationally accepted norm. He has actually implemented that. And there's a reason why whenever he used to talk, so there used to be a continuous flow, spontaneous flow of subject matter without any interruption, because he used to write and he used to frequently refer that matter. So that is really a commendable one and also exemplary. And all other engineers and also engineering students, we have to follow his method of study. And another important thing is his sensation was complete and perception without self-serving biases. So my take a holistic decision making, and there is one accumulative sensory processing disorder that happens, but he is free from that, and he used to see his sensation was complete, not incomplete, and perception also. Many of us are not creative because of a sensory dominance, usually visual dominance, or other 4 senses: touch, sound, taste and smell, and brain dominance, usually left brain dominance or right brain dominance. And we see in him a balance of left brain and right brain. Okay, so there's a reason why he used to he has complete observation, and he was a whole brain thinker. He was a patient, empathic, and intuitive listener with a deeper rate of all multi-sensory intuitive convergence and integration. And we see, so many of us are poor listeners, but the greatness of his is, even though he has attained international status. So if a cameraman comes, our point of empathy, from their point of view, I think listening. So I think that's the reason why he's not self-centered or ego-centered. So then he was also a music lover. When he admitted during an interview of Western instrumental music, Beethoven symphony, and Tyagaraja Kirtanas. He was a good swimmer. He was general captain during his graduate study at Agran Engineering College and played basketball, cricket, table tennis, hockey, and swimming. And National Board of Accreditation (NBA). So it defines 12 characteristics of an engineer as program outcomes. Surprisingly, we find in him all those 12 characteristics. His love of profession reflected in all of his various works. He confirmed the truth of Khalil Gibran's saying that work is love made visible. He was a voracious reader, keen manual recorder and prolific writer. He wrote many articles on current issues of theatre. He loved Telugu literature. He learned. Okay. So if you see, he speaks, let us together learn new things, starting from and then become. So you can explain to me the deep sense of standard model of standard model of big bang cosmology, latest maths and exploration of cosmos using this from the zero. The trouble is when one understands wrongly zero and then build up. See how practical. To me, many times the deep sense of Big Bang cosmology, latest satellites, and research on gravitational waves. Not only engineering, but also multidisciplinary implement. So, he from whom all beings arise and by whom all things are created, by facilitating to the perfect performance of his own beauty. That's mankind imperfection, sinking. This is translation by Dr. Saravachi. So, Sri Hanumantha attained such perfection. Through his work, he has attained Siddhi. His de-evaluation was a part of the wisdom of the ultimate answer is to see things as they are, unclouded by the disruptions of self-concern. Such perfection. Through his work, he has attained a part of, as per the wisdom of Jiddu Krishnamurti, see things as they are, unclouded by the now because of the increasing water conflicts, insight and far foresight. He was former Director General, Engineer-in-Chief rank of Water and Environment Training and Research Institute, Valamtari, a training institute of Irrigation Command and Development Department, Government of Andhra Pradesh. He was former Chief Engineer, Telugu Ganga Project, Major Irrigation, and Chief Engineer, Minor Irrigation of Government of Andhra Pradesh. He was the Chairman of the Institute of Engineers India, Andhra Pradesh Center during 1988-90. He also worked as Commissioner of Tenders, Government of Andhra Pradesh. He was former Chairman, Technical Commission, Water Conservation Mission, Government of Andhra Pradesh. His contributions. Engineer T. Hanumantha Garu has published 92 technical papers in Indian and international journals. He published 4 books: Type Designs for Lift Irrigation Schemes in India, Type Designs, Radio Economic Tables for earthen dams, Manual Designs for Minor Irrigation Projects, Innovative Participatory Technology for Watersheds, Low-Cost Structures on 4 Waters concept. I think now his tables, Radio Economic Tables for earthen dams designs are now still popular. So by name, Hanumantha Garu's tables, not only in irrigation department, but also in the forest department, where they construct earthquakes. That means earth dam constructions. Where they use Hanumantha Garu's tables. Still oak. So that shows the importance of his practical insight, and also 4 waters concept. So it's being used in Rajasthan. Okay, so. For watershed management, the 4 waters concept is being used there. So as a Chief Engineer in Irrigation, he coordinated to bring out a booklet on guidelines for preparation of project reports for surface water minor irrigation works, for which Dr. N.T. Ramarao Garu, who was then Chief Minister, had appreciated him in his foreword in the following words. So Mr. Engineer T. Hanumantha Rao, Chief Engineer, Minor Irrigation, has done innovative work in standardization of designs, preparation of ready economic tables, and issuing guidelines in the shape of manual for preparation of detailed project reports for minor irrigation works. I appreciate this pioneering activity in the sphere of minor irrigation. So at Director General of Valamtari, he made it mandatory to do diagnostic analysis of irrigation systems in irrigation projects for all officer trainees of Valamtari. As a trainee officer at Valamtari, I also prepared diagnostic analysis report of irrigation system of Sridham Sagar project. So after superannuation from the state government service, he worked for over 2 decades as technical team leader, consultant for the following 9 international organizations in 22 countries. During visits abroad, he has also solved several varied problems related to water resource engineering and civil engineering for the ongoing projects in these countries. In the World Bank, United Nations Operations Project Services, IFAD, International Fund for Agricultural Development, Rome, CARDA, Center for Integrated Rural Development for 15 Asian and Pacific countries, WAPCO's International Assignments, German Agro Action Germany, DFID, Department for International Development, Government of UK, Swedish Project Development, Kingdom of Netherlands government. He gave inaugural address in many of the national international conferences. He delivered the 27th Dr. Ian Kusla Memorial Lecture during 29th Engineering Congress organized with the Institution of Engineers, December 18, 21st, 2014, on the topic Making Rivers Live and Interlinking Rivers, a new concept. He proposed the technology of constructing a series of barrages on rivers to make them live and make possible interlinking of rivers. He also applied for patent for this technology. His awards and recognition is awarded Best All-Rounder Cup for proficiency both in sports and studies during his graduate study in Calcutta Engineering College. He was recipient of Central Board of Irrigation and Power Government of India Award 1989 for outstanding work in water resources in India. He got Bharat Ratna Sir Mohammed Viswesvaraya Award in 1987 for outstanding contribution in the field of engineering, jointly instituted by the Institution of Engineers India and Government of Andhra Pradesh. He was recipient of Visishta Seva Patram, the highest honor of Andhra Pradesh State Government in 1986 for outstanding work in government service. So I just read his message released on United Nations World Water Day on March 22nd, 2016 at Gopuraj Rangaraj Institute of Engineering and Technology, Hyderabad. So let us together continuously update our attitude towards water, using Laos mutual cooperation quotient among nations, states, communities, and individuals. So he defined the Laos quotient. L means listening attentively and intuitively, both verbally and non-verbally, without selective listening and preconceived judgments due to sensory dominance and brain dominance. O is observing with all senses without selective perception due to accumulative errors of sensory information gathering and sensory information processing. V, verifying intention, honest or dishonest, communication, masks people wear to hide true self, misperceptions, psychological games from not okay position, negative thinking patterns, performing surprisal errors, social context, and values, both eternal and temporal, of oneself and others. And E is empathizing with others, as everyone has unique mindset, unique emotion set, and unique body set. And S is self-awareness, accurate expansion by appropriate self-disclosure of feelings and receive functional feedback. Simultaneously receiving biased and unjust dysfunctional feedback from events, situation, and people. So may the soul of his modern rest in eternal peace. May his indomitable spirit of universal compassion beyond borders guide all the stakeholders of water management towards water wisdom all over the world, towards the sustainable development and peace. And before I leave, I just read the Telugu poem of Dr. C. Narayan Reddy Garu. Okay, so by very famous Jeevana Bhashyam, because it is relevant to his achievements in life. పరుల కోసం పాటుపడిన నరుని బతుకు దేనికని, మూగ నేలకు నీరెందివని వాగు పరుగు దేనికని, జల్లుకు నిలవని ఎండకు ఆగని చిల్లుల గొడుగు దేనికని, పద పద పదమంటూ పదములే కాని కదలని అడుగు దేనికని, ఎంతటి ఎత్తులకెదిగినా ఉంటుంది పరీక్ష, హిమగిరి శిరసే మాడితే అది ఏరవుతుంది, బిరుదులు పొందే వ్యాప్తికి విలువేమి సినారే, చెరగని త్యాగం మిగిలితే ఒక పేరవుతుంది. థ్యాంక్ యూ వెరీ మచ్. థ్యాంక్ యూ ఆల్. వెంకటేష్ మార్వాడిది చెప్తారు, నేను చెప్పట్లేదు, బయట నేను చెప్పిస్తాను నేను.
I request for Hussein, the convener of the event, kindly invite today's speakers, Dr. Venkatesh Marwade.
Okay, so it's really a great opportunity and privilege to introduce Dr. Venkatesh Marwade. So he is a PhD in Civil Engineering from the University of Texas at Austin, August 2004. MSc in Engineering Hydrology, National University of Ireland, December 2000. And Bachelor of Engineering, Environmental Engineering in Shivaji University, India in 1997. His interests or GIS applications in water resource engineering with specific focus on river channels, surface water hydrology, river hydraulic, cyber infrastructure hydrology, water in developing world. Now he is a professor of a prestigious university, Purdue University, one of the prestigious universities in Purdue University, and he belongs to Lyle's School of Civil Engineering, and honors and awards at university level. He is a graduate student mentorship award from the Purdue University College in 2022, highly commended paper award from CIWM for journal article in the Journal of Flood Risk Management, and Purdue University's Seed for Success award given to all principal investigators and co-investigators, the garnering awards of 1 million or more in 2018. So Indian Water Resources Association Outstanding Achievement Award for works related to flood prediction and mapping for Indian streams in 2018. So Indian Geographic Information Council's Excellence for GIS Award in Education and a non-profit category for soil-based floodplains maps for Indiana in 2017. Purdue Civil Engineering Roy E. and Myrna W. Wasnik Research Award in 2016, Seed for Success Award, Purdue University Award, given to all investigators garnering research funding of $1 million or more in 2014, Purdue's Zimmerman Civil Engineering Innovation Award in 2011, co-recipient of the Quentin Martin Best Practice Paper Award for the journal article linking GIS, hydraulic modeling, and Tapu research for optimizing water level monitoring network in South Florida in the ASC Journal of Water Planning and Management. Outstanding reviewer for the ASC Journal of Hydrologic Engineering, Irish Comment Fellowship for pursuing MSc in Ireland, and ranked first at the May 1997 Bachelor of Engineering exam for Shivaji University, India. So with students and colleagues, and he was also he has got with colleagues Adnan Razib first award he got graduate first place winner at the 2016 Association of State Floodplain Managers Student Paper Award, Jessica Holberg Award, and Siddharth Saxena Award. So at Purdue University level, and Adnan Razib Award he got, and Sanjeev Kumar Award, and at Purdue University. So and many times he got, and Monica River Casado, winner of Young Scientist Outstanding Poster Paper Award. He got along with his graduate student, and he has got professional affiliations: American Society of Civil Engineers, American Geophysical Union, American Water Resource Associations. So I welcome you, sir, and he has conducted many workshops. So I welcome you, sir. For your, and at the outset, I thank you profusely, sir, in spite of your busy schedule. So you are kind enough to be with us online and to view this lecture. And you know you're considered to be international expert in flood mitigation measures, and you know the soil erosion. So due to the floods, the soil erosion goes away. So the agricultural land, so the excess of agricultural land comes down. So I think definitely your topic throws light on this flood mitigation measures using the computational tools. So I welcome you, sir. Thank you.
Thank you. Can you hear me?
Yes.
Okay,
Yes.
so yeah, I want to thank Professor Hussain for giving me this opportunity, and I want to thank all of you. So I just want to give you a flavor of some of the projects that we have done to address this issue of water management. So most of my work is about using data, computational tool, and cyber infrastructure, which is what I will present. As I said, this work has been done by several students. So here I just acknowledge them. So you can see their names, and many of them have graduated with their PhD, and they are working in different countries as faculty and researchers. So since the topic is about sustainability, so I just want to quickly define what I mean by that. So we want to provide access to clean water to meet
Yes, sir.
our current and future
Sir, please,
needs.
would you please switch on your video, sir? Venkatesh?
Okay.
Yeah.
Yeah.
Yes.
Okay.
Okay.
Um, So we know that water sustainability is threatened by human actions and environmental change, including hydrologic events, extreme hydrologic events. So I know many parts of India is experiencing floods and drought these days, and so are many other countries. So what we try to do in our research is to address these issues by using data, computational tools, and cyber infrastructure. And here I just want to give you some examples of how we do it without going into a lot of details about the actual projects. So what you see here is a hydrologic system. So I think many of us or many of you know these things. So what we try to do here is simulate this process. So our main driver is rainfall, and how that rainfall gets distributed into different components such as evapotranspiration, runoff, infiltration. That is dictated by how we manage our land and also the engineering infrastructure we have. So what we try to do is simulate this process using different tools and try to understand what is going on with our hydrologic system. So to do that, we need a lot of data. So these are some of the data sets that we use. So we use land cover, we use soil data, we use elevation data, we use hydrogeological data, and then we also use groundwater data. So as I said, we want to simulate and improve our understanding of hydrologic system by using data, computational tools, and cyber infrastructure. And so what I'm going to do now is give you some examples of how we are trying to do in some of our projects. So the first example that I'm going to present is how the historical and future land use and climate change will affect the availability of water in Ohio and Upper Mississippi River Basin. So these are major river basins in the US. So what you see on this slide is how the land use has changed in the Ohio River Basin. So the map on the left is in 1935 and the map on the right is 2015. So mainly you can see the urban area has increased in some locations, but at the same time, the green, which is the forest area, has also increased significantly in the eastern part of the US. So the idea is, now that the land use has changed, how has that affected the green and blue water? So by blue water, we mean the water that we have in rivers, aquifers, lakes, and reservoirs. So this is the water that we humans use for our domestic needs and industrial needs and irrigation and so on. So what you see on the slide are arrows. So an arrow going up is that the blue water has increased, and arrow going down means it's decreased. And the color shows the magnitude of that increase. So on the left, you see areas where the land use has changed. And then below that, you also see areas where the precipitation has changed. And then in this map, you get a sense of areas where the water availability has increased. There are some areas, for example, the light color, where the water availability has decreased. And then you see these other areas where you see a dash. So these are the areas that have not experienced any significant increase or decrease in water availability. We also want to look at green water. So green water is the water that the plants use for or the agricultural use. So this is the water that is stored below ground and circulate within the water cycle through evapotranspiration. So again, what you see in these areas, there are areas where the green water has increased, which means that the groundwater has increased and it is contributing more to evapotranspiration. And we get a lot of evapotranspiration where we have agricultural and vegetation activities. So in one of the images that we saw earlier, we saw that the eastern part, the forest area has increased, which also means that it is using more green water and it is contributing to increased green water availability. So that was how the historical land use and climate has affected water availability. So what we are going to see next is how the future land use is going to affect our water availability. So this is the upper Mississippi River Basin. So again, this is very adjacent to the Ohio River Basin that I just showed you. And here in both projects, we are using this model called SWOT, which stands for Soil and Water Assessment Tool. And we are using that to see how the land and climate will impact availability of water. So on these maps, you see again how the surface runoff will change. And surface runoff, when the surface runoff changes or increases, we have more flooding. And as the evapotranspiration gets affected, that affects the availability of water that we have for vegetation and agricultural activities. So we combine the impact of both surface runoff and evapotranspiration to create what we are called this ecosystem efficiency index. So the idea here is that if the efficiency index is low, then we have environmental issues that need to be tackled. If the environmental efficiency or ecosystem efficiency index is high, then it may not be that. So the idea again here is how we can use these computational tools to provide maps like this that the decision makers can use to make decisions on where to put resources on managing water and other environmental concerns. So in this project, this was a project done in Kenya. So in Kenya or in East Africa, many NGOs come and build these sand dams. So these are low-head dams. And I think many parts in India also have these dams. So the idea here is the NGOs have built hundreds or thousands of sand dams in Kenya and Tanzania. So the question that we are asking is, can we quantify whether these dams have created any impact? And if the answer is yes, can we quantify that impact? So those of you who are not familiar with this, as I said, sand dam is a low-head dam. So the idea here is that these are sandy rivers. So when you build a barrier, a lot of sand gets accumulated upstream, and also a lot of water gets stored. And because of sand, there is less evaporation. So there is more time for that water to be used for domestic and agricultural activities. So this is how it looks in the field. So this is the dam, and upstream you can see it is filled with dams, and this is downstream. This is how it looks when there is more rain. When there is rain, you can see there is some water upstream, and you can see this dam is actually not working properly because the water is seeping under the wall. So again, the idea was these NGOs, they build these dams. So are they really effective? And if they are effective, can we quantify that impact? So to do that, we use satellite data. We also use data from this model called FLDAS. So this is created by the Food and Agricultural Organization. And then we also use a vegetation index to see if the dams have impact on agriculture or land, then that should be visible in this vegetation index map. So what we try to do is we try to create a computer model for that area and try to simulate the hydrologic system, and then try to compare what we are getting from the model with the data that we have, which is the gray satellite data. And what you see on these graphs is the difference between the what model was showing and what the data was showing. And based on these differences, then we can see whether the water storage has been impacted by these dams. So what we saw is that the sand dams do have impact on water storage, but the satellite data that we used, which is the GRACE satellite data, it was not able to capture that change in water storage. So again, that has to do with the resolution of data that we have for GRACE, which is very high, or in this case, very coarse. And the impact that we have from these sand dams are very localized. So that data set was not effectively capturing that. So instead, what we try to do is we use the vegetation index map through NDVI to see if we are able to see increase in green cover wherever these sand dams have been built, and we were able to see that. So again, instead of focusing on all the numbers here, the p-value less than our significant level means that we are seeing significant impact. And this is the map that we can see what has been observed in terms of the change in NDVI and what we can predict based on that. So again, the idea is that the what we saw upholds our hypothesis that sand dams have positively impact vegetation, and we don't get impact on vegetation unless there is impact on water. So we were able to capture the impact that we saw from the sand dams using these NDVI maps. In this project, what we are trying to do is we are trying to see if we can quantify river discharge at all locations in the Ohio River Basin. So this is the Ohio River Basin. The area of this basin is about 5 lakh kilometers square. And we have about 700 gauging stations. So one may think that 700 is a lot of gauging stations. But if you zoom in on the top right, you will see that there are several rivers where we don't have a gauging station, which means we don't know how much water is flowing through those streams. So unless you don't know how much water we have, we cannot really make decisions on how to manage that water. So the idea here was to create a model that can give us accurate prediction of water that is flowing through all these streams in the Ohio River Basin. So to do that, we used, again, we used this model called SWOT. And as I mentioned earlier, this uses all the data set that we discussed earlier, digital elevation model, which is topography, land use, soil, and stream network. Many projects use only field collected data, and since we want to capture all the hydrologic fluxes which are not measured on land, we also use satellite data to drive this work. So the idea was to use field collected data, satellite data, and to come up with an accurate prediction model that can tell us how much water is flowing through all rivers in the Ohio River Basin. And many times we use one model which is just one conceptual representation of what that hydrologic system is, and that may not be accurate. So instead of using one model, we propose to use multiple models and then combine the results from those models to get predictions of flows in the river basins. And eventually we wanted to create, if there is high flow, will it cause flooding? So we wanted to start with rainfall and end with stream flow, and also with a flood map that can show us where we are getting flooding if the river flow is high. So what you see on this slide is results from that model. So you can see we are able to get river flow, which is the blue part that you see in this in the left image. And then on the right, if we zoom in, we can see how much area will get flooded as a result of that rainfall. So the idea was to create a flood prediction model for the entire Ohio River Basin, which will be driven by rainfall. And then we wanted to compare that with what was observed. So the indices that you see here, when they are close to 1, we get a perfect match, but you can see we are close to 0.8, 0.9. There is little bit of uncertainty, but again, that is okay because even the observed maps, they do have some uncertainty in that. So as I said, instead of using one model, we want to use multiple models, multiple data sets. And instead of coming up with one prediction, we come up with an ensemble. And then instead of creating one map, we create a probabilistic flood map. So many times what we do is we do these studies and you end up with a map. And what the map says is if you are inside a certain line, and I think in India, we call these red zones. So red zone is divided by or dictated by a line. If you are inside that line, you will get flooded. If you're outside that line, you will not get flooded. But most of the times, that's not how it works. The idea here is that to assign probability to a location and say that there is certain level of probability that this area will get flooded or not flooded. So this is something that we have been propagating for a long time. Instead of having a deterministic flood map, we want to have a probabilistic flood map and assign probabilities to area that will get flooded. We wanted to create and test a hydrologic system for predicting flooding from extreme events. So for example, just few days ago, Gujarat experienced this cyclone. So we do get a lot of hurricanes in US. So these are extremely large events, cause a lot of damage and flooding. So the question is, can we simulate a system like that and come up with areas that will get flooded and use that for making lot of computational resources. So what we are trying to do here is we are trying to create a system that will do a lot of computational modeling, detailed computational modeling in areas where we don't need detailed information. So on this map, you see this green area, which is going to be using a lot of computational power and resources. And then upstream of that, we will use a simple model to just get the flow. So again, another example, this is a very urban area where we want to do detailed modeling. And then there are areas which are not so urban or not many people live or we have infrastructure there, so we don't need a detailed model. So with this hybrid modeling, we end up with a result like this, where you get a lot of information, detailed flood inundation information. So by detail, we mean that it tells us what areas will get flooded, then it will also tell us at what time these areas will get flooded. So again, this kind of information will be useful for decision makers in managing relief and rescue operations when we have flooding. So I will just play this so you can see as we are getting rainfall, these areas that we use a very detailed model, you can see it is showing us how the area will get flooded. And as the rainfall stops, the flooding decreases. So this is a dynamic map that is showing the extent of rainfall both in space and time. So we used that model to simulate this hurricane, which was in 2017. So we got about 40 inches, which is almost 1,000 millimeter of rainfall in less than 4 days, and it caused a lot of flooding in a city called Houston. So we wanted to see if we can use a system like this to predict the amount of flooding, the extent and the time where the areas will get flooded. So again, we had to use this hybrid approach. You can see a lot of detailed modeling along rivers, and as we go upstream, the mesh gets coarser. And this is the result from that. So you can see a lot of area got flooded. There are two major reservoirs upstream, and you can see those reservoirs also got filled up. And as they fill up, you get more water going downstream. So we created that system. Then we wanted to see how accurate our prediction of flood depth is. So we compared our results with what was actually observed on the field. And these are the locations, the red dots that you see on the map. So these are the locations where FEMA, which stands for Federal Emergency Management Agency, so they had measured how deep the flood water was, and we compared their observations with what our model showed. And you can see our predictions and what was observed, many of them are falling along this 45-degree line, and you can see the R square, which is very close to 1. So what this is saying is that the depth of water that we predicted and the location where the flooding was predicted, it was very accurate. So again, the idea here is that we have a system that can, in advance, it can tell us what areas will get flooded and what time they will get flooded when we have an extreme hurricane event, or a cyclone, as we call those events in India. So if we are expecting a cyclone or a hurricane, then we can use a system like this to find out what areas will get flooded, so we can move people and take care of some of the infrastructure. So what I'm going to show in the next few slides is just the images that were showing flooding and where our model showed flooding. So you can see this is where the model is showing flooding, and those areas did get flooded. So again, these are the highways. You can see they went underwater, and that was predicted by the model here. Again, many areas, whole city was flooded. So we wanted to see whether the extent that we saw with our model was actually flooded during the event or not. And you can see that that was the case from these images. So the goal here is that we want to have a system that can give us how much water we have at any location. So what you are seeing on this slide is simulation for Wabash River Basin. So I live in a state called Indiana. So Indiana is mostly covered by this Wabash River Basin. So what you see here is an area of about 85,000 kilometers square, or very close to 1 lakh kilometers square. And we can simulate the hydrology of this system by using a model that can tell us what will happen if we have a rainfall event. So this is just one simulation for Wabash River Basin in Indiana. So again, the idea here is to get as much detailed information as we can when we have these extreme events. So what you see here are road networks. So instead of just predicting flooding along a river, we also want to predict whether any neighborhoods will get flooded, whether any highways or roadways will get flooded, so we can make decisions about that. So this is an animation of flooding for the city of Indianapolis. So this is the river that flows through the city. Besides the river, you can see there are lots of these patches that you see. So this is the flooding that some of the neighborhoods will see when we have an extreme rainfall event. So many times our flooding is not just a result of rainfall, but it also a result of poor management of infrastructure. So many times our stormwater drains, they are not able to handle the flow. So we are also trying to incorporate those details. So not just the natural river system, but also engineer systems into our hydrologic models so we can see where we'll get flooding when we have extreme rainfall. So until now, what I showed you was a lot of work, lot of computational resources, lot of data. So what you see here is a flood map, and this flood map was created by just using soil information. So soil stores a lot of history with it. So can we use that history to see what area was flooded historically? So by using some of the attributes that we have in soil data, we were able to create a soil map. So the red map that you see here was created by just using soil, and the green map that you see here was created by spending millions of dollars and a lot of engineering data and work. And you can see the data, the map that we create from soil is very similar to what you get by spending all these resources and money. So again, the idea here is, can we also use simple approaches to create a flood map? This is a flood map for the entire US, and this map is created just by using soil information, nothing. So all this is capturing historical information from soil and mapping which areas have experienced floods. And these maps match very closely with what we call the 100-year return period flood. So by using this map, you can delineate red zones for any location. So again, this is just by using soil information created by few graduate students in 1 month. We are also using these days a lot of machine learning. So instead of using all this computational power, can we improve our prediction or predict stream flow by using machine learning? So again, without going into all the details, if this number is close to 1, our predictions are accurate. So you can see we are closer to 0.8, which again is acceptable in many situations. Machine learning, these are black-based models. So data goes in, results come out. We really don't know what is going on. So one way to have some confidence in those machine learning approaches is to also include some physics. So we are incorporating simple physics, just water balance, and some simple equations into machine learning to improve our prediction of stream flow. And we are seeing improvements in our predictions. So finally, what I want to show here is we do a lot of work, we do create a lot of results. So the idea is, how can someone use this information for making decisions? So how can we make this information accessible on the web so anybody can access this and see what is going on? So to do that, we are creating systems where we can publish our models and results. So one of our product is called SWOT Share. So as I mentioned earlier in some slides, we use this model called SWOT, and many people in India also use this model. So we do a lot of work, we put in a lot of efforts. So many times those results just stay on our computer or in some report. So what we are trying to do here is creating a system where people can upload and publish their models and results. So this is the Ohio River Basin model that we created for that project. So we published this in an interface called SWOT Flow. So the idea here is anyone can come, click at a location. So if I click at a location, I get information about that location. And then I can click and then I see this hydrograph. So hydrograph is just showing how much water we have at any given time. So I click, I zoom in, I click, I get the location of the river. And then after picking a particular flow, I see what area will get flooded from that particular flow. So anybody can go in, look at that location and see what areas will get flooded for that particular amount of flow during that day. We use a lot of data. Many of these data sets are not easy to access and process. So we have created tools where anybody can go and get data for their area of interest. So we are calling this system as HydroGlobe. So you can get remote sensing data for any region in the globe. So that's why we are calling it HydroGlobe. Another project that I'm working on is called Remorphis. So many times we are interested in figuring out or finding out how much water is flowing through our rivers. But most of the times we don't even know how our rivers look like. So what we are trying to do in this project is we are trying to create a repository of river morphology data, in this case, bathymetry data. So we are creating a three-dimensional representation of rivers. Right now, we are focused on rivers in US, but eventually our goal is to have a system like this to work for any river in the world. So what you see on the left is a three-dimensional representation of river, how the actual river looks like underwater. Now, in order to create this, we need data, and many places don't have data like this. So what we have in this system are tools that will create a synthetic bathymetry or synthetic river bed for any location in the US. And some of these tools use some observed data, some simple shapes. Even in some cases, it can use a triangle or trapezoid or a nice parabolic shape. Or if there are any observed data, it will use that data, use a deep learning model and come up with cross sections for that region. And then you connect those cross sections to create a mesh. And from that mesh, you can create a three-dimensional structure of river. So that is what you see on this image. So again, I just would like to summarize what I presented here. And I know I finished this little bit quickly because we started late and I have to be somewhere in next 15 minutes. So we have access to a lot of multi-scale geospatial data, and these are providing opportunities for us to understand and simulate hydrologic system. So if we want to manage water resources, we want to know how our hydrologic systems work. And what I showed you here are some of the tools that we are using to do that. Some of these things do require a lot of computing and data, but then we can find an optimal approach by depending on the problem that we have and the data that we have. And finally, by using cyber infrastructure, we can make a lot of this work accessible to people who really need it and who need this information for making decisions if you want to manage our water resources sustainability. So with that, I will stop. As I said, I went through these slides rather quickly, but if you are interested in learning more about any of our projects or the slides I presented, please feel free to contact me. So here I'm giving you my contact information, my email or my Twitter account, and also my web address. So with that, I thank again Professor Hussain and all of you for attending my talk, and I'll be happy to answer if you have questions. So thank you very much.
Sustainable management of water resources using data, computational tools, and cyber infrastructure. Well, everybody wants to ask any questions. When you make already have questions, you can prepare this email. Family members, his son, Mr. Kota Vijay Kumar, candidates that we were supposed to participate. You like to? Hello. I think Dr. Hussain has talked about the father. His work and his stamina has got his all the models.
Voice is not clear, please. Chairman?
Now, okay. So I have nothing much to say about his work. All of you are in the same field and you know about him. As I look at him, he was a very honest man, a very simple man, a good man. And he was very hardworking. Why I say this? He always used to tell me. He always used to tell me that we do not come from a very high intelligent talented pool. The only way you can come up is to work hard. That is the only key, and that is the only way to succeed in anything you want to do. But there were times where his insistence on empirical means of solving problems or tackling issues, I didn't agree with. As a non-empirical person, I know there are certain ways of doing things, not limited to the empirical process. So we get truths. I go this way, we go this way. So
We are not able to hear, please.
he believed in that process. I didn't believe in that process 100%. As he believed, I thought that different ways of doing things and different ways of doing problems. But we agreed at one point. He said, and I agreed, was that you don't try to find answers to your problem. Finding answers to your problem will never solve the problem. You should focus on finding solutions to your problem. When I asked you, where are you basically getting these problems from? My belief is that every question which you're trying to answer comes from the answers you have already been given. You want to confirm whether that answer is the right answer or not, and the questions keep springing up in various different forms. The one thing I agree with him is not to find answers, but to find solutions. Then we had discussions. So very find the solutions to problems. And we go with his experience. The solution is hidden in the problem. Try to understand the problem more and try to go deeper as you can. And the solution automatically springs from the problem. It is a hidden key which is within the problem. And I admired this man. He was a good man to me. He was a great father. And we never talked about loving each other, but we just had it. And so it was a very interesting process which I went through. And I'm happy. And it was a good man. Thank you.
Chairman, we are not able to hear.
If the car is not turned on, check the cable connection from the to press the source button below.
Center, and I'm sorry, I'm not and all the esteemed members who are with us today who have raised this endowment lecture, and I see quite a few members who are here. And we are deeply appreciative and thankful to Dr. Hussain who has coordinated the whole program so well. Every year, and all these various speakers and then Victor organizations who have always supported in making our lecture very popular. Thank you, sir.
Actually, more medals and certificates in our district, but unfortunately, only we received from Wesley University morning 11:30. The result was announced on Monday, and other three results are not announced. IIT Hyderabad, the NIT Warangal, we have not received the names of the students who have the toppers for the last 4 years, 90 to 23 in the subject of civil engineering.
Chairman,
So we have received
are you able to hear members? We are not able to hear.
Since there was no time, I asked her to come on the Zoom meeting. I don't know whether she is meeting. She is attending. My request is to be available. Kindly you can collect the medal and the certificate. It has in the time, so accordingly we will have a lot of programs in the coming days. One of the major programs on the stage and and I think madam this in future we should do 1 year later because the result is every time very late. June is the program, result is coming after beyond this date. So last year also it came like that, then we called them and some people is like it was day after. So it's better now the three results will come next month. So next year we can avoid it. So that will be better idea. Instead of the same year it is not possible. The results are not being sir, last name is Mr. Vikram. I have the same name. I have already he collected the matter.
Can see you.
This year, candidate 2018 okay. We need 2019 okay. And obviously it is not yet. So that is the reason I am not able to call them for validation of matters.
Thank you, sir. It is my pleasure to propose a word of thanks. Respected Chief Guest and Speaker, Dr. Venkatesh Agarwal, Professor, Department of Civil Engineering, Graduate University, University of IIT Telangana State Center, Dr. Muhammad Hussain, Professor, Department of Civil Engineering, Hyderabad, and convener of this event.
చైర్మన్ గారు వీళ్ళు మాట్లాడితే అవసరం లేదండి. రత్న గారు వినిపిస్తుందా మీకు? మాకు చూడండి అప్పటి నుంచి కూడా చెప్తున్నాను చూడండి. ఓకే రైట్ అట్లే మీకు
on behalf of Telangana State Center of IA and on my own behalf, I convey our sincere and profound thanks to Dr. Venkatesh Nirwal, Professor Department of Civil Engineering, Pati University, for gracing the occasion as the chief guest and also as a speaker and deliver a lecture on the advanced topic in the field of civil engineering. Thank you, sir. I congratulate the gold medal winner. I would like to express my gratitude to this past presidents of IA, past chairman of IA, Telangana State Center, past honorary secretaries of IA, council members, committee members, corporate members, and others who made it convenient to attend both in physical mode and also in virtual. I request all of you kindly join our program celebrations, which will start immediately after this program in our main and also I request you to join for the dinner which is arranged after program celebrations. I request all of you kindly stand for a national anthem.